Everyone, Radko Tutor here explaining. In this video, we are going to look at how to assign oxidation numbers. Alright, how to calculate oxidation numbers in given molecules or compounds. Now, in my previous posts, I have actually elaborated or depicted some rules for assigning these oxidation numbers. So if you're on YouTube, you can kindly just go on my Facebook page, follow the page, and you'll be able to see the rules that I've stated or that I've assigned for you to be able to calculate oxidation numbers. Alright, now here we are going to have some examples and see how we can calculate these oxidation numbers of elements in molecules or compounds. So what we're going to do is, let's say if we are saying that find the oxidation number. So our first question is we are going to find the oxidation number of nitrogen in ammonia, NH3. Now, how can you find the oxidation number of nitrogen in NH3? What you can simply do there is you say, remember, start by identifying if this molecule given has a charge on top there or not. So by looking, that molecule has no charge. Now for you to assign the oxidation number of nitrogen, what you can simply do is you say nitrogen plus, you get the hydrogen. How many atoms is hydrogen having? So hydrogen is having 3 atoms. Now you also need to ask yourself a question that in what state or what oxidation state does hydrogen contain? So hydrogen in this case, it is coming as a nonmetal. Alright, so if it is coming as a nonmetal, meaning that it contains a charge of -1 or oxidation state of -1. So you are going to have 3 times -1. And then from there, equate that to the total charge of this molecule given, which is, in this case, it's a 0 because we don't have any charge on top of that molecule. Then from here, you are going to say we have nitrogen, 3 times -1 is -3 equal to 0. Then it will be nitrogen is equal to, if we are to take the -3, the other side of the equal sign, it will be a +3. Therefore, nitrogen has an oxidation number of +3. So the oxidation number of nitrogen is +3. That's how we simply calculate the oxidation numbers. Alright, now we go to question number 2. So question number 2, let's try to calculate the oxidation number of P, which is phosphorus, in PO43 negative. Now for you to calculate the oxidation number of P in PO43, what you can do is you start with the phosphorus. Phosphorus is just alone, it has no any other atom. So in addition, so you can just get it as P, then plus you go to oxygen. Remember, we've already said that oxygen has oxidation number of -2 in our previous notes, and therefore we can say that we have the 4, which are the number of atoms, multiply that with the -2, which is the oxidation state of oxygen, and then equate this to the charge of the molecule, which is -3. Alright, now from here, what you can now do is solve that equation and find the value of P. That means you've gotten its oxidation number. Now we are going to have P is equal to -3, or maybe before that, let me first multiply 4 times -2, we get -8 is equal to -3. Then from here, we can now make P the subject of the formula. So to do that, we can say that P is equal to -3. -8, when it crosses the equal sign, it is going to form a +8. And therefore, we shall have our P being equal to -3 plus 5 is a +5. So what does this mean? This means that the oxidation number of phosphorus is +5. Alright, we can still do some more examples so that we can just perfect our skills and see how we can understand this better. To do that, we are going to question number 3, where we are going to calculate the oxidation number of Cr, which is chromium, in Cr2O4. That's what we are going to do. All right. Now, here we are calculating the oxidation number of chromium, and in this case, chromium is having a 2 down there, which is showing that chromium has 2 atoms, or we have 2 atoms of chromium in that order. Now, for you to calculate the oxidation number here, what you can simply do is to say you have that 2 of chromium, you can bring it in front, which is going to be 2Cr, like that, to show that we have 2 of the chromiums. And then plus you go to oxygen. Oxygen is having 4 atoms, meaning that we are going to multiply the 4 atoms with the oxidation state of oxygen, which is -2. All right. Then from there, equate this to the total number of charge that you've been given on that molecule. And in this case, do we have any charge on top there? We don't have. The charge is 0. So that means we are going to equate this to 0. And then you'll be able to calculate the power, or rather the oxidation number of chromium in this case. So we are going to have 2Cr, 4 times -2 is -8, is equal to 0. Then we can take the 8 the other side of the equal sign, so that from the left hand side we can just remain with the chromium. So we are going to have 2Cr is equal to +8. Now, in this case, if we are to divide the 2 to both sides of the equation, meaning that we are now going to remain with the chromium alone. So we are going to divide this by 2 by 2, and therefore the oxidation number of chromium is going to be +4. So that's how you get to calculate the oxidation numbers. All right, to do our final example, we can say we can calculate the oxidation number of, so this is going to be example number 4. So we are going to calculate the oxidation number of Mn in, that is manganese, in MnO42 negative. Now in that case, we are going to say that we are calculating for this. So we can say we have Mn plus, we have 4 atoms of oxygen, so you can say 4 times the oxidation number of oxygen is a -2. And then we are going to equate this to the charge of this molecule given, which is a -2. And to finalize our answer, we can now say we have Mn minus 8 is equal to -2. From there, we can make the manganese to be the subject of the formula, so that we get its oxidation number. Now we have Mn is equal to -2 plus the 8. When it goes the other side, it becomes a +8, and therefore we shall have Mn being equal to a +6. So that tells us that the oxidation number of manganese is a +6. So basically that's how you get to calculate the oxidation numbers. Now I'm going to give you some task that you are supposed to do. Please feel free to inbox me your answers. I'll be able to check and correct you where you are not okay. All right, so now I want you to calculate the oxidation number of, so I want you to calculate the oxidation number of number 1, Fe. So calculate the oxidation number of Fe in Fe3O4. Also calculate the oxidation number of S in HSO7 2 negative. Also calculate the oxidation number of P in H2P2O7 2 negative. So I want you to calculate the oxidation number of these atoms here in these compounds. All right. Thank you so much for watching my videos. This is The Radical Tutor. See you next time, but please don't forget to follow my Facebook page. If you're on YouTube, kindly subscribe so that whenever I post videos, you are notified that The Radical Tutor has posted videos. See you next time. Bye-bye.